Next topic is correlated subquery. The correlated subquery is nothing but a query or the subquery that uses the values of the outer query. Okay. In the case of non-correlated subquery, so far what we discussed, the subquery and the outer query are completely independent. Whereas in the case of correlated subquery, the subquery is dependent on the outer query. That is what mentioned. The correlated subqueries are dependent on the outer query. For each row processed by the outer query, the correlated subquery is executed. Hence, it will slow down the performance. Hence, you need to be diligent whenever you use the correlated subquery. Okay, this correlated subquery will cause performance issues. That doesn't mean you are not supposed to use correlated subqueries. This only if the situation demands, you don't have any other way of. In that case, you can use correlated subquery. Okay, because it has its performance issues or anything. The result of the correlated subquery depends on the current row of the outer query. That's all. Okay, the current correlated subqueries are often less efficient. This is what I said compared to non-correlated subqueries. Previously, we discussed about non-correlated subqueries. Currently, we are going to discuss about we are discussing about the correlated subqueries. It is less efficient compared to non, because the inner query will, each row of your inner query will execute it for the corresponding outer query. Okay. So in this case, if you see the syntax, select from, this is a common thing, where column 2, you will select max of column 2 from table 1, where column 3 is equal to outer, this is your outer query, okay, outer dot column 3. Okay, so in this case, in this table column, the outer query tables column, you are using it as part of your inner query. Got it? This is what your outer query, right? Including the outer, okay? And in this is what your inner query. This is what your subquery or inner query. This one is your outer query, okay? And this is what your inner query. So in the inner query, what you are doing is you are using a column from your outer query in the where clause. So in that case, what will happen is this query will get, the subquery will get executed for every row for the corresponding row from your outer query. Hence, the performance will be very, very slow. Okay, very, very slow. Limitations, okay, that is what your correlated subquery. Okay, I just give you an example for correlated subquery. I just go back here. Yeah. Here already I have the correlated subquery. Look here. A subquery depends on the outer query. Subquery uses values from outer query. These 2 points, if you remember it from the interview point of view, that is more than sufficient. What is subquery here? This is what is subquery. This subquery is depending on your outer query. Why? Because the depart number column, you are using it from your outer query, E1. So E2 dot depart number is equivalent to E1 dot depart number. That is what this one. Okay. Hence, this query will get executed for every row of your outer query. Let's say in your outer query, you have 5 lakh records are there, 500,000 records are there. For each record, this query will get executed. Hence, the performance will be very, very slow. Unless otherwise required, don't ever use the correlated subquery because it has a serious performance issues. It is working fine. Okay, what is the, alternate, how do you rewrite this query to avoid outer query in this case? Sorry, to avoid the correlated query, right? How do you deal with this? Simple, right? Same thing. So guys, remember, once you get into a company and when you are working in a project, you may have to have the skill set to rewrite the query, existing query. So this is a query written by someone else in your team. So what you do is you know very well what it is going to do. So you remove all the nonsense crap here. You don't need the column from in this context, okay? You just execute these two queries. Both of them are produces how many records? Both of them produce 6 records, right? And almost all the values are same, but the sorting order is different. Forget about that. Okay, 756 is there, and the 7698. Almost all the values are same. The output is same, almost same. Only the sorting, that is, you forget it. The values are same, right? In both the queries, number of records and the values are same. Both the queries produce same output, but this one is pretty faster compared to this one. So I'm going to select this one, and you will find something like here. Include displays. Look here, I selected these two queries. Here you can see something like display estimated execution plan. At the bottom, you can see that here, executing query is produced here. Okay, I do one thing. I just select this one. Okay, and here I do select this one. You can see this is the execution plan for this query. Okay, nested loops, inner join, and if you see the thing here, right? Can you see the cost here? Estimated operating cost, CPU cost, all the things are there. IO cost, operating cost, inner join. Okay, I just select this one and see what is happening behind the scene. Look here. So this, it's something like your GPS. If you want to go from your home to office, it shows the map, but it gives you the alternate route also, right? Show me an alternate route. It will show the alternate route. So you wanted to go from your home to office in a pretty fast manner because you're already late. Which route you use? You take a shortcut, right? When you use a shortcut, you reach your office in a pretty fast manner. Look here, in this case, both the query, though both the queries produce the same output, this query, if you can see the map here, right? Nested loops, here also using compute scalar. To fetch the data, it underscores this many number of things. But whereas when you select this query and if you click on the display estimated execution plan, so many things are. It has to work hard to fetch a record because it's so many processes are, right? But, in this example, you can understand the non-correlated subquery is pretty faster. It doesn't require too much of cost. And whereas here it requires a lot of cost, it requires more time to process the data. But there are situations you have to use the correlated query. Actually, in that case, you have to use it. Okay, for example, you cannot use the non-correlated subquery all the time. There are situations you may have to use it. In that kind of situation, you can use it. But how do you? The intro, they'll ask you, okay, what is the difference between correlated, non-correlated subquery? Even a just past guy, the freshers, he can answer it. But you need to show the difference. Okay, the difference between these two are the non-correlated subquery performance pretty faster because the subquery gets executed only once, whereas in the case of correlated subquery, the subquery depends. So the subquery gets executed for each row of my outer query, hence the performance will be too bad. So how we evaluate it is, we have something called estimated execution plan. I selected the query. On top of this, right, I can see in the menu display is the estimated execution plan. When I click on it, I can see the execution plan here. It's something like your GPS, okay? Which route is pretty faster, right? That is what it shows. So if you talk all the things, it's this execution plan, all the things, believe me or not, even the 8-year or a 10-year experience people, they do not know what exactly the execution plan, all the things, okay? Fine. I just, okay. So now we understood what is correlated subquery. And the next question is, what is the difference between the correlated and, the next question is, sorry, the limitations of subqueries. So subqueries can impact your performance. Okay. See, it is not that the non-correlated subquery will be faster all the time. You can also use joins in place of subqueries, right? So to avoid using the subqueries. Subqueries itself will impact performance. That too, then correlated subqueries, it will literally slow down your performance. like I said, right, from the complexity and readability point of view, right, extensive use of subqueries can make your SQL statements very difficult to read and maintain. Okay, so in that case, what you can do, you can break your complex nested subqueries into CTEs, common table expressions or temporary tables to improve readability. Okay, and sometimes it can also boost your performance. These are the tips, guys. Remember this from the real-time point of view. They can ask you, from this point, these kind of questions. Okay. So, okay, you're saying that, use of subqueries, makes the logic to be difficult to understand, and, and the readability is a little bit challenging. So, how did you overcome this? So what we did, we just went through the logic, used in the subqueries, and then we have broken the complex nested subqueries into CTEs, common table expressions. What is common table expression? That I will discuss it later, okay? And that is available only in SQL Server, okay? But also, most of the time, the call subqueries are inefficient. Like I said, okay, I have given you the demo using the estimated execution plan, right? And limited reusability. Subqueries cannot be nested more than 32 levels deep. What is nested subquery? A subquery inside a subquery. Likewise, how many subqueries you can nest it? A subquery inside another subquery inside another subquery. So 32 levels only you can nest it. That is the limitations when it comes to subquery. Okay, so far we discussed about what is correlated subquery and non-correlated subquery. And correlated subquery is pretty inefficient compared to the non-correlated subquery, because in the case of non-correlated subquery, the inner and outer queries are completely independent, and also the inner query executed only once in the case of non-correlated subquery, whereas in the case of correlated subquery, the inner query is depending on the outer query. The inner query gets executed for each row of my outer query, hence it will degrade my performance. And also we have seen as part of the subquery, right? We've seen all the different types of subquery, Sela subquery, nested subquery, multi-row subquery, and then we jumped on to the correlated subquery to understand the difference between these two. Okay. Next one is the inline view. So like I said, you can use a subquery from your where class, select class, and join class also, from class also you can use it, okay? The inline view, okay? So in the case of real world scenario, when you are in a project, they'll use all these terms. During the status call, the customer tell you, why don't you use an inline view? So why are you using, this query, right? So in that case situation, you should be knowing, first of all, what is inline view. Inline view is nothing but using a, you can use a query in your from class also. That is what your inline view, okay? It is a subquery in the from class that acts as a virtual table for the duration of the primary execution. That is called your inline view. I just give an example for inline view also. Let me see if I have written any query already. Nothing is there. Okay, what I will do is I'm going to write, instead of wasting time writing the same thing, I just I just select this one. I think it must be there somewhere. I just department name from employee E. Okay, I'm going to give some alias. You don't have to specify as all the time, but it is good practice. You can use as, okay. And E dot, let me know, here what I'm going to use E dot E name. What is E? E is the alias for the employee table. E is nothing but employee table, employee dot E name. And here what I do is a D dot D name, and before that E dot salary. because whenever you use more than one table in your query, you have to use the alias. That's the best practice. And in the from class, what I do is, I have used the MP here, right? And yeah, in the join also, you can use the inline view. So in this case, in the join class, what I'm going to do is I'm going to use the select depart number and average salary from employee table. Okay, and group by okay. As for this query, I'm going to use a alias called let's IV or something like that. Okay, IV, and whenever you use join, okay, whenever you use a join clause, you have to use on. Okay, and followed by this, I'm going to say e dot depart number is equivalent to IV dot depart. Okay, and next one is what else we can hear now. If you want to use yeah, we'll do one thing. Okay, this is the one. So this query is nothing but a output. Okay, this is considered as a table. Okay, this is considered as so the output of this one is the table, right? So this inline view, this is called your inline view. This inline view, what it does is it calculates the average salary for each department, group by department. Each department find out the average salary. This result set, I just named it as IV. The output of this query is nothing but IV. Okay. You just think, the IV is nothing but a temporary or virtual table. This virtual table will exist only for this query's execution. Okay. So the main query or the outer query, okay, then joins this inline view with the employee and department tables to get the names of employees who earn. Okay, I want to display the employees. Who, in this case, I'll just do one thing. Okay. Okay, here group by as IV all department number. Next one is I'm going to use a join here and depart D as D and on E dot depart number. Sorry, on E dot depart number equal to IV dot depart number. Sorry, D dot depart number. Okay, so yeah. This one I'm going to use IV dot department. Join this output with department table on E dot depart number is equivalent to D dot depart number. Okay. D dot depart number where E dot salary is greater than IV dot salary. So what is IV? IV is a temporary table. Okay, here I need to specify as salary. Okay, that's why this one is so average or else or salary. Okay, or I just put no average salary. So this is my inline view. Okay. So what this one does is it calculates the average salary for each department. The output of this one, I named it as IV, the alias. I've given a name as IV. Okay. So in this case, the main query, it joins this inline view with the employee and department. So look, the department is a table. Okay, department table to get the names of employees whose salary is greater than the average salary of their specific department. Okay, I just execute and show you what is happening here. Okay, it's working fine. So this is what is in this example for inline view. Okay, as I told you, right, you can use you can use email, select, here also you can use select clause, also you can use the query, okay, the subquery, select max of salary from employee, from employee. Then you can select this one. So, okay, here, okay, salary, comma, max of salary. In this case, what is happening? You can display the total salary on, side by side with the salary of each employees. Okay. So 10,058, okay, 10,000 is the maximum salary. You can display that one. So, okay. So you can use the, mm, okay, here I use it, right? Okay. So this is another example for, yeah, right. This is what I want to show you. Two things, okay. This is inoperative. Previously, I was writing the part number and right. So, here, see, now you understood. You can use this subquery in your select class. Even the join class also you can use. See, in the from class and join class, you are supposed to use the table name. Instead of using the same query here in the from class, in the join class, have you used it? Okay, in the join class, have you used it? I want you to rewrite this query. Okay. And then in the from class, you can use this logic, and the join class, you can use the department table to join it with the output of this one. Okay, give it a try. Okay. So the what you need to do is the instead of employee table, you can use the this column here, this query here. Okay. But in this query itself, you can select the the e dot name, all these three column values, you can use it. And then you name it as ID. And then the join class, what you do is you can use the employee table, and then you can join the department table to the employee table. You can do it that way. Okay. You can change the order here. Okay. Instead of using the query in your inline view query, okay, followed by join, you can use the from class, and the employee table you can use it here. Okay. You can exchange and see it, how it works. So now you understood, the different types of subqueries and where and all you can use subqueries also we have seen it. What is inline view also we have seen it. Okay, they use the term called as inline view. The inline view is different from the